Today for stats homework, we're going to be taking a look at discrete probability distributions, specifically the mean and standard deviation. We're also going to do a little bit of graphing here, and we're going to make use of some pretty common online resources to get this done. Naturally, and especially for this first problem, we could be doing all of this, just on graph paper, but with the online resources that we have, it's a little bit easier to look at this. And I'm assuming that we are all pretty good at creating histograms by now. So here's the problem. Airlines typically accept more reservations for a flight than the number of seats on the plane. Suppose that on a certain route, the airline accepts 40 reservations on a plane that carries 38 passengers. Based on experience, the probability distribution y equals the number of passengers who actually show up for a randomly selected flight is given in the table. You can check that mu of y is equal to 37.4 and sigma of y is equal to 1.24. There's also a crew of 2 flight attendants and 2 pilots on each flight, and let x be the total number of people, passengers plus crew, on a randomly selected flight. Our first task here is to go ahead and verify that mean and standard deviation. And for this, I'm going to use my TI-84 calculator. A little later on, we're going to show how to do this with Staplet apps if you happen to be online. But this is good enough for right now using that TI-84. From the home screen here, we're going to push Stat and Edit, and that'll bring us to the lists. A common thing here to do is to put all of the numerical outcomes in L1, and then all of the probabilities in L2. Then we're going to go back to the home screen, and then Stat again, calculate one variable statistics. Now the key here is that the list of numerical values is what you put in list, so L1, and the probabilities go in the frequency list, so L2, and then you push calculate. And really quickly, that gives us the mean over here, 37.4, and the standard deviation, 1.24. So those numbers look correct. Now we have a discrete probability distribution for y, but we don't have one for x yet. So why don't we go ahead and make that? X is going to be the number of people on the flight, so the number of people will be my first row, and the second row will be the probability. Now if 35 passengers are on the flight, and then there are 2 flight attendants and 2 pilots, then there are actually 39 people on the plane. Similarly, if we have 36 passengers on the flight, and there are 2 flight attendants and 2 pilots, then the total number of people on the flight is 40. And that kind of continues all the way down the chart. Now for the probabilities, the only thing that really is a probabilistic outcome is the number of passengers on the flight. So if 35 passengers leads us to 39 people on the flight, then that probability for 39 is the same as the probability for 35 passengers, which is 0.1. Same thing with for 40 people on the flight, that's going to have a probability of 0.1, and all the way down the table. Now, if you're pretty good at reading these charts, you can kind of see that there is a peak forming right around here. At 35 is definitely, or at 42 people on the plane, that's definitely the highest part of the probability distribution. But we're going to go over to the Staplet, and we're going to try and get a histogram going on. Bringing up my web browser, I'm going to go to staplet.com, and this is a nice list of web apps that you can use for statistics. And I'm going to go to discrete random variables. We're going to start filling out the fields here, so that a variable name here is the number of people on the flight. And let's see, the first amount would be 39, and that had a probability of 0.1. And then also 40 had a probability of 0.1. We'll hit this plus sign over here to add a few more rows. And then fill out the rest of the table. And then really easily just click Begin Analysis. And this calls up that histogram almost immediately. And it also gives you the summary statistics. So here our summary statistics is 41.4 for the mean, which we knew already, and 1.241 for the standard deviation, which again we already knew. And we also have that confirmation that the peak over here is going to be at 42. Now remember, we didn't really need to see the histogram. If we had a good sense of how the probability distribution worked, we could have seen right off the bat that that peak would have been at 42. We also would have seen that this is a approximately symmetric distribution. Coming back to the problem here, which of the following correctly describes the shape of the graph for the probability of x not shown? Well, we did the probability graph for x, and it is basically the same graph for y. In answering the question, the probability distribution for x, the number of people on the flight, is approximately symmetric. And that takes care of that first problem. Now the next one here is, what is the value of mu x, and interpret this value. Remember that since I created the distribution for x, it is possible for me to calculate that mean, and it is 41.4. The other way to look at this is, in order to get x, we needed to take all the values from y and add 4 to them. In other words, x is equal to y plus 4. Using the law of probabilities for discrete probability distributions, then, we should know that the mu of x equals the mu of y plus 4. So when you add a value to all of the outcomes in one distribution, then the mean of the new distribution is the old mean plus that same value you're adding, which is, of course, is equal to 41.4. The second task here is to interpret that value of 41.4. And for that, I have a sentence frame that I use over and over again. And of course, I would share this with all of my students. But if many, whatever the random variable is, are chosen at random, then the average random variable would be about average. Now we're just going to fill in the blanks here. So if many, and here we're talking about flights, so if many flights are chosen at random, then the average number of people on the plane would be about 41.4. Now having that sentence frame really simplifies the problem. You don't have to keep on reinventing how to interpret a mean. So it's a good thing for you to have written down somewhere. The last part of this problem would be to find the value of sigma x and to interpret that value. We already saw from both my calculator, we didn't do it on the calculator, we just did this on Staplet, but we already saw from Staplet that the standard deviation is 1.241. Let's figure out how we got to that number. So we already know that x is equal to y plus 4. The number of people on the plane is equal to the number of passengers plus 4. And what we notice here is that to get to x, we do not multiply y by anything. In other words, it's not like we're doing 2y plus 4. It's just y plus 4. The only thing that would change a standard deviation is multiplication. Adding 4 to a random variable doesn't change the standard deviation. So if I need to find sigma x, well, that's just going to be the same as sigma y, because the 4 isn't going to change the standard deviation. So if nothing's going to change the standard deviation, then it's going to stay the same. Now the problem gave the standard deviation as 1.24, so we'll just keep it at 1.24 just to appease the way that this problem goes. Now for the interpretation of that value, we've got another sentence frame. So this sentence frame says a random variable typically varies from the mean of mean by about standard deviation units. So we're going to fill in the blanks. Our random variable was number of people on the plane, and that typically varies from the mean of 41.4 by about 1.24 people. Now along with this goes the what you're going to need to do is to adjust this for readability. So a number of people, that's probably better expressed as the number of people. And I don't know about that plane. Maybe we should say the number of people on the flight. So now we'll read that one more time and ask if this sounds good. So the number of people on the flight typically varies from the mean of 41.4 by about 1.24 people. And that sounds really good. People over here might feel a little bit redundant, but you could take it out or leave it in. Doesn't really matter. So that's the end of this problem. Hopefully you guys can get this all figured out. So have a good one, and we'll see you next time here for more stats homework.